Hello math learners! We have already discussed the integral exponents from our previous discussions. Specifically, the positive exponents, the negative exponents, and the zero exponents, which is a part of the law of exponents. Today, we're gonna level up our discussion and we're going to talk about the rational exponents. In this video, you will learn how to simplify expressions with rational exponents as well as know the techniques in order to find the final answer. But before anything else, hit the subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! Welcome to another session here in Math Learning with Sir Ash. This is still your free access math teacher Ash, and today we're going to discuss the most essential learning competency-based lesson for quarter 2 of the grade 9 mathematics, which is all about rational exponents. Question is, what is a rational exponent? If you could still remember, the definition of an exponent is that it is a small number being raised or being written in a given base, in which this small number will represent how many times the base will be multiplied by itself. Now, in the case of rational exponents, your exponent, which is the small number, becomes a rational number. When we say rational number, it is commonly referred as a fraction. Now, the notation of a rational exponent is given in this form, raised to the power of 1 over n, where your 1 over n represents your rational exponent and your b is the base. Now, what does this mean? If you encounter this kind of expressions, it means that you will get the root of the given base. In this case, if ever you want to get the root, let's say that is your a, which is the principal root of this given notation, what you can do is you will find numbers in which when you multiply your a, you will arrive to the value of your b. Now, example of that one is this. Let's say we have 9 to the power of 1/2 is equal to 3. Now, as you can see, 9 here is the base with an exponent of 1/2. Now, in this case, the root of 9 is equal to 3. Though we know that the root of 9 can be positive 3 and negative 3, but the principal root is positive 3. Now, how did I get that one? Basically, there are two ways to solve this one. In most books, commonly, we use the radicals. But since our focus for this session is all about rational exponents, I will show you that this can be solved without using radicals. How is that so? It is by the application of what we have learned in the law of exponents. Now, 9 here is basically a composite number, meaning it is not a prime number. You can break this down. And what are those breakdown for 9? That is 3 times 3. Right? Because 3 times 3 is equal to 9. In any case, this 3 times 3 means 3 squared. Now, if you change this notation to the given number, which is 9, that will give you 3 squared to the power of 1/2. I did not change the fraction or the rational number. And I just changed the number 9 into 3 squared. Got it, right? Now, if you have this kind of expression, you can apply the power rule of the law of exponents. When you have an exponent being raised to an exponent, what you can do is you can multiply the exponents with each other. So, 2 times 1/2, that will give you 2 over 2, which is just the same as 3 to the power of 1, and which is just equal to positive 3, and that is just the same. Easy, right? Now, let's consider some examples. Okay, math learners, we have here 3 examples for us to have a concrete idea about the concept I just introduced earlier. We have 8 to the power of 1/3, 64 to the power of 2/3, and 32 to the power of negative 3 over 5. Now, what you can do here without using the radicals is you can get the prime factorization of 8. Now, what are the prime factorization of 8? 8 is basically 2 times 2 times 2 to the power of 1/3. Right? Because 2 times 2 is 4, and another 2 will become 8. If this is the case, you can simplify these factors into 2 cubed raised to the power of 1/3. Now, you can apply the power rule. 3 times 1/3 will give you 3/3, so that is equal to 2. So, your final answer is 2. Easy, right? Now, let's go to 64. Now, for 64, we have an exponent of 2/3. What you can do here is first, you break down your 64. 64 can be broken down in many ways. You can break this down into 2 and 32. While 32 can still be broken down into 2 and 16. While 16 can still be broken down into 2 and 8. While 8 can still be broken down into 2 and 4. And 4 can still be broken down into 2 and 2. So basically, you have 1, 2, 3, 4, 5, 6. 6 prime factors. Okay, so what you could do here is you just write 2 to the power of 6. And then you copy your rational exponent. And then, you apply the power rule. 6 times 2/3, that will give you 12/3. And then you simplify 12/3. 12 divided by 3 is 4. So you will have 2 to the 4th, which is just equal to 2 times 2, 4 times 2, 8 times 2, 16. And that is your final answer. Easy, right? Now let us go to our problem number 3. That is 32 to the power of negative 3/5. Remember that if you encounter negative exponents, what you will do is you get the reciprocal of that one. So this will become 1/32 to the power of 3/5. Now, remember this in your final answer, my dear math learners. In getting the final answer of your rational exponent, the first one you need to consider is that you must not have a rational exponent in the denominator side. And then, you must have a final answer with no negative exponents. So those are the two considerations for you to have your final answer. Now, let us continue. We have here 32 to the power of 3/5. Okay, so we will break down our 32. And if you could still remember our example here, we have here the 32, right? And we have 32 is being broken down into this. So how many prime factorizations? 1, 2, 3, 4, 5. We have 5 factors, okay? So that is 2 times 2 times 2 times 2 times 2. And that will give you 1/2 to the 5th power raised to 3/5. Now, in this case, we'll just simplify this using the power rule. So that will give you 1/2. 5 times 3/5. That will give you 15/5. And your final answer will be 1/2 to the power of 3. However, 2 cubed can still be simplified. So 2 times 2 times 2. And that will give you 1/8. So this is your final answer for your 3 problems. Easy, right? Now, the next question is, what if we will encounter some variables and some constants? Okay, math learners, we have here 7 examples or 7 exercises for us to really understand the concept of rational exponents. Now, we have our first problem. Simplify the quantity a squared b cubed to the power of 1/6. Now, this is an example of the product to power rule. So, what you can do here is you just multiply your exponents to the outside exponent. Okay, so 2 times 1/6, that will give you 2/6. We have here 3 times 1/6, that will give you 3/6. But since this can be simplified, or 2/6 and 3/6 can still be converted into its lowest term, then we will convert the 2/6 into 1/3, while the 3/6 into 1/2. And this will be your final answer. Easy, right? Now, let us go here. Now, we have our second problem. P to the power of 1/4 over P to the power of 2/4 raised to the power of 8. Now, what you can do here is you can solve this into 2 methods. The first one is by the use of the quotient rule, then the power rule, Or you can also use the power rule, then the quotient rule. So in this case, since I am dealing with fractions, I will first use the power rule. So I will multiply my outer exponent to the exponents inside. Okay, so I have p to the power of 1/4 times 8. So 1/4 times 8, that will give me p to the power of 8 over 4. I also have here 8 times 2/4, so that will give me p to the power of 16 over 4. Now, as you can see, 8/4 and 16/4 can be simplified. So 8 divided by 4, that will give me 2. So that gives me p squared. 16 over 4 or 16/4 can still be simplified into 4. So that will give me p to the 4. However, since they have the same base, I can apply the quotient rule, but since the denominator has bigger exponent than the numerator, then this means that I will have 1 over p squared. Because 2 minus 4 is negative 2. So I will have p to the power of negative 2. And remember, your final answer must not have a negative exponent. So I will get the reciprocal of p to the power of negative 2, and the answer is 1 over p squared. Easy, right? Now let us go to our third example. We have 5 to the power of 2/3 to the power of 3/4. So here, what you can do is you just multiply the fractions, which is an application of the power rule. So you copy the base, and then 2/3 times 3/4. In multiplying fractions, you just multiply the numerators, and then you multiply the denominators, and then simplify. So 2 times 3 is 6. 3 times 4 is 12. And 6 over 12 can be simplified into 1/2. And that will be your final answer. Easy, right? Now, let us go to our fourth example. What if we have this example? 3 to the power of 5/4 times 3 to the power of 1/4. Now, this is an example of the product rule. So, having the same base, you will just copy it. And then you will add your exponents. So 5/4 plus 1/4, that will give you 6/4. And 6/4 can be simplified into 3 to the power of 3 over 2. And that will be your final answer. Easy, right? So now we have here our fifth example. We have x to the power of 2/3, y to the power of 1/4 to the power of 1/2. So this is just the same as the product to power rule. So what we can do is we multiply the exponents. So 2/3 times 1/2, that will give us 2 over 6. 1/4 times 1/8, that will give us 1 over 8. Now, is this the final answer? Not yet, because 2 over 6 can still be simplified by its lowest term. So that will become x to the power of 1/3 y to the power of 1 over 8. And this will be your final answer. Easy, right? Now, let us go to our next example. We have p to the power of 3/2 to the power of negative 2. So, I just applied the power rule. So, this will give me p to the power of negative 6 over 2. Because negative 2 times 3 is negative 6. And then negative 6 over 2, I will simplify that one. That will become negative 3. Is this the final answer? Not yet, because our exponent is still in negative. So what we can do is we get the reciprocal by applying the negative exponent rule. So this will become 1 over p cubed. And this will be my final answer. Easy, right? And now, last but not the least, is this one. What can we do if we encounter this kind of problem? So since this has the same base, remember in the product rule, you just copy the base and then you add the exponents. So that is 1, because there is an invisible 1 here, plus negative 2, plus 5 cubed, to the power of 2. Okay. Now, I will solve first the expression in the quantity. So 1 plus negative 2, that will give me negative 1. Negative 1 plus 5 cubed. So that is negative 1 plus 5 cubed. I will get the LCD. This will become negative 3 plus 5. And negative 3 plus 5, that is positive 2 over 3. So therefore, the simplified answer for my exponents in the quantity is m to the power of 2/3. And since I still have the outer exponent, which is 2, I will now apply the power rule. So 2 times 2, that will give me 4 over 3. And this will be my final answer. Easy, right? So I hope you have learned the concept of the rational exponents with the process of the law of exponents. Now, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, math learners, I hope you have a wonderful time on our discussion for today. This is still your free access math teacher Ash. And always remember, it is fun to learn mathematics if we are together learning. If you do have some questions, inquiries, or confusions about our topic, do not hesitate to put your inquiries in our comment section below. Thank you for subscribing, liking this video, and sharing this to your friends, classmates, and schoolmates. Thank you, God bless, and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click the subscribe button and notification bell. Thank you.